All right, everyone, I'm here to help you with number 2. The curve with the equation ax plus b plus c over x, and x is the element of all real numbers, and x cannot equal 0, has a minimum at point 1, 4, and a maximum at -1, 0. Find the value of each of the constants a, b, and c. They actually gave us 4 pieces of information here. So the first information is that we have the point P, and that is definitely on the curve. And we have the point Q, that is on the curve. And then it says that we have a minimum at 1, 4. So we have a minimum at 1, 4. Minimum has a horizontal tangent, which means the slope is 0, which means the derivative is 0 at x equals 1. And we also have a maximum at Q, which means we have a horizontal tangent, which means the slope is 0, so the first derivative is 0 at x equals -1. Okay, so let's just plug in the information. So I'm going to plug in this first into the original function when y is 4, x is 1, c over 1 is just c, okay? So we have 4 equals a plus b plus c. This will help us later on. Now I'm going to plug in q. So I'm going to plug in when y is 0, x is -1. And then I have c over -1, which is -c. So 0 equals -a plus b minus c. That will also help us later on. Okay, now for 3 and 4, I need the derivative. So I'm going to take the derivative. First, let me rewrite the equation as ax plus b plus c to the x minus 1. So when I take the derivative, I'm going to get the derivative of ax is a, the derivative of b is 0, and then the derivative of this would be -1c x to the power of -2. So the derivative is like a minus c over x squared. And for number 3, I know that the derivative is 0 when x is 1. So 1 over c to the c over 1 squared is just c. So there's another equation for us. And then in number 4, I already took the derivative, so I'm going to set the derivative equal to 0 when x is -1. So I would have minus c over -1 squared. So 0 equals a minus c. Well, that gave us the same information. Okay, so what I'm going to do with this, so I don't really need this, okay. So what am I going to do with this is I am going to solve for a by adding the c over. So a equals c, okay. So now I'm going to plug in a here for c and a here for c. So in this one, I'll have 4 equals a plus b plus a, because a is c. So 4 equals 2a plus b. And in the second one, I have 0 equals -a plus b minus a, because a is c. So 0 equals -2a plus b. Okay, so I'm going to put these two on top of each other. And I'm going to add to solve by elimination. So I get 4 equals 2b, so b will give me 2. I found b. So let me plug in b to here. So 0 equals -2a plus b is 2. So -2 equals -2a, so a would equal 1. And we know that a and c are equal, so c also equals 1. Okay? All right, then number 9, given the function f of x equals x squared minus 3bx plus 2c Determine the values of b and c such that, so they give us a point 1 comma 0, and they said that the first derivative is 0 when x is 3. Okay, so I'm going to start with the point 1 comma 0. So when y is 0, x is 1. So I have 0 equals 1 minus 3b plus c plus 2. So I have 0 equals 1 minus 3b plus, oops, I didn't do anything. I'm going to add these numbers. So negative 3b plus c plus 3. And then I'm just going to subtract the 3 over. So I have negative 3b plus c equals negative 3. That's going to be one of our two equations. Now for the second equation, I have to take the derivative. So let me take the derivative. The derivative of x squared is 2x. The derivative of negative 3bx is negative 3b. And the derivative of c plus 2 is 0. Because like these are just, b and c are constants. So it's like a constant. The derivative is 0. Okay, so the derivative equals 0 when x equals 3. So I have 0 equals 6 minus 3b, negative 6 equals negative 3b, b equals 2. And then I'm going to plug that into there to solve for c. So negative 3 times 2 plus c equals negative 3. Negative 6 plus c equals negative 3. So c equals 3. And then finally, number 14, the normal to the curve at blah, 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 at the point 1, 2 meets the axes here and here. Okay, so we need to find the equation of the normal, okay? So to find the equation of the normal, we need a point, which we have. We need a slope. So to find the slope, I'm going to take the derivative. The derivative would be 1/2 x to the negative 1/2 plus 1/3 x to the negative 2/3. So that's like 1 over 2 root x plus 1 over 3. It doesn't matter. I'm going to leave it as x to the 2/3. The reason it doesn't matter is because they're really nice and they gave us the y value. The x value is 1. So let's find the derivative at x equals 1. Thank goodness, they're always so nice to us. So we have 1/2 plus 1/3. That would be 3/6 plus 2/6 is 5/6. Okay, so the slope of the tangent is 5/6, which means the slope of the normal is negative 6/5. So I have y equals negative 6/5 x plus b. My y is 2 when my x is 1. So 2 equals negative 6/5 plus b. 2 plus 6/5 equals b. So then that's 10/5 plus 6/5. b is 16/5. So y equals negative 6/5 x plus 16/5. Okay, so that's the normal. So the normal meets the axes at, so basically it wants us to find the x-intercept and the y-intercept. So let's start with the x-intercept. To find the x-intercept, we're going to set y equal to 0, x plus 16/5. I'm going to subtract 16/5. And then I'm going to divide by negative 6/5, which means, remember, I keep, change to multiplication, and flip. So I would have negative 16 over negative 6, which reduces to positive 8 over positive 3. So we have 8/3 comma 0, which means a is 8/3. And then to find the y-intercept, I'm going to set x equals to 0 plus 16/5. So I get y equals 16/5. So I have 0, 16 fifths, so B is 16 fifths. Okay? I hope that helps. Have a wonderful day.